So when you have something like that, when you have a log of a base well, any base, you can make the high go high and the low go low, and then that is clearly 1, isn't it? So that's 69 times 1. It's just 69. Didn't even need a calculator. David.
What's the base on the log on the bottom two?
Yeah.
What's that base?
Good question. You tell me. When the base isn't showing?
1, 0,
10.
10.
So we have two understood bases. They're the two buttons on your calculator. Regular log, log, base 10, and ln, which is natural log, said backwards, logarithmic natural, which is base e, right? So those are the two understood bases which they don't show. So if every log has a base, so if they write the log word or the ln word and they don't show the base, if it's the regular log word, the base is 10. If it's ln, the base is e. Now, you don't need to put those 10s in there. I'm not saying you need to do that or anything, but that's what they are. All we care about is that's just a big old 1, huh? Because it's the same thing over itself. Is that good? Mr. Karenbachus, do that one with you? Here. All right. Can you do that one? Try to do the same kind of thing we did before. Right? So it's ln, make it a little bigger here, ln e to the minus 5. Like that. So what are you going to do with that negative 5? Powers go to the front, right? That's that quality of logs where powers go to the front. So negative 5 ln of e. Now, let me ask you this. This e they have right here, is that lowered down? Like those cars that are lowered? Is it lower? No, it's on the level. It's just regular. So that means it's not the base, right? Remember, base just means bottom. Like these are called what? The base boards because they're on the bottom, right? So base means bottom. So therefore this e is not the base because he's not lowered down. He never was, right? It's just on the level. So that means there's another base that's not showing, and it's an e also, right? Because ln's unseen base is e. So put it in there. Does that make sense? There's always a lowered down number for a log. Always. If they're not showing it, it's 10 for regular log or e for natural log. So put it in there. The other e is on the level, so it's not the base. So there's what we really have. So what? Well, then how do we finish this problem? It's negative 5, and then what do we do with this? What is that going to be?
1.
It's going to be 1 again because the high goes high and the low goes low, right? Remember, you can make it 2 logs. That works for natural log or regular log or any log. When you have 1 log, you can turn it into 2, and the high goes high and the low goes low, which means that's just a big 1. Right? That's 1. So it's negative 5 times 1, so it's negative 5. Good on that? All right. So for this one, what I'll do is I'll just tell you a rule, and then I'll do my best to give you the reason. If you just had to take a wild guess, maybe you already know. You did some of these with Mr. Karenbachus. Do you know what the answer to that is? It's just the 7. Yeah. The 2 and the log 2 cancel, and the answer is just 7. So first off, that's the rule. I think that's right. My other class told me Mr. Karenbachus wrote it like this. A to the log base a of x is just x, right? Didn't he write that? Right? When the power matches the log base thing, they just cancel, and the answer is just whatever the other piece is, the x, in this case, the 7. And that's true. That's exactly the truth. So the answer is just 7, just like that. Now, you can remember that rule, or you can. What if you didn't remember? What if you're in the middle of a test, next exam, which is weeks away, exam 3, and you're like looking at that, and you're like, I don't remember that fancy rule. How am I going to do this? You could do that one by hand, right? You could remember what you could do with this logs up here. I'll say or. You could just go the high goes high. Oops. The low goes low. Like that. Remember, you can always turn 1 log into 2. Is that rule making more and more sense? Getting more and more comfortable? You can always turn 1 log into 2, right? Just the high goes high and the low goes low. And you can just hit this, just go 2 to the power, and do these on your calculator, hit equals, you'll get 7. That's one thing you can do. You know, that'll come out 7. Yeah. How about I just leave it at that? That it'll come out 7. Like that. Is that good? Well, you know, I'm a math teacher, so I like reasons for things myself. So let me do one more. You don't have to. If you do that, good. You're good. That's great. But I personally like reasons. So let me just give you the reason why the base and the power thing, log base thing, cancel each other out. I'll prove it. Here's a proof. Yeah, in math, if you go higher math beyond calculus, some of what you do is you prove things. You show that they're really always true, all these rules we learn. So here's how a proof would go. If you wanted to show that this just equaled 7, you would just say, well, I'm going to call this power part up here by the name x. Let's call it x. I'm going to say x equals log base 2 of 7. Does that make sense what I'm doing? Am I totally confusing you? So I'm just saying, hey, power, it's like naming a pet or something. You're Rover, and I'm saying, hey, power, you're going to be called by the name x. So this problem, instead of 2 to the log base 2 of 7, it's 2 to the x now, isn't it? You with me? Do a little proof. I hardly ever do this. Just one little proof to prove it's always true. So, right? So I just called it by the name x. That power is called x. I could have called it y or z or Joe or Tom. Right? I just gave it a name. Okay, so what? Well then, use the rules. What I'm showing you, when I say proof, what I mean is show that it's consistent with the rules we already know are true. What rule do we already know is true? What will happen if I cross off that log? What's the golden log rule? What's the first and most fundamental rule we always use for logs? When you lose a log or gain a log, when you lose or gain one log, when you lose the log or gain the log, what happens? The base stays the base, the other two switch. Right? You good with that? We're going to use that a lot today. I call it the golden log rule. It's the first one, the most fundamental one we use a lot. When you cross off a log, or if you gain a brand new log that wasn't there, either way, gain or lose a log, base stays the base, other two switch. So who's the base? The 2. He's the low down one. Base means low down, right? The base stays the base. The other two switch. The x and the 7 will switch, right? So instead of 2 to the 7, it's 2 to the x, 7 goes over there, right? You with me? That's not anything new. That's the fundamental golden log rule we've always used. Okay, so what? Great. Well, that shows me that 2 to the x is just 7. So what? Well, remember, I called that whole power x. And so the question they're asking me, the original given question, trying to erase, the original given question, which is 2 to the log base 2 of 7, is really 2 to the x, isn't it? Because I called that whole power thing x. And what does 2 to the x equal? According to this. Proven. You see? All of that is 7. It's really just a fancy use of the original golden log rule. All right, I don't know if you enjoyed that or not. That's a proof. That's logical steps showing it's always true. That's the kind of thing you do in some higher math classes. Can't afford the time. We can't afford the time. All right, so let's take a look at this one. So basically they want us to use the log rules. Do you remember? They're going to keep hitting on those 3 log rules. So remember the power one we've been using. Powers come down to the front. That's one of them. The other 2 log rules, remember how adding becomes multiplying? Subtracting becomes dividing? Those 2. So those are the 3 rules. The adding, multiplying, subtracting, dividing, and then the powers come front. Those are the 3 log rules. So this one is adding. So adding for 2 logs, same base. The base doesn't change. Log base 16. It's like that 16 is just glued to the g. We're not messing with the base at all. It's not going anywhere. So 2 logs added, how's the rule go? Becomes 1 log with the 8 and the 2 times. It's a times there. It's a scribbly times. Multiplied. Is that good so far? Right, remember that log rule, right? Remember the easier operation for 2 logs becomes the harder for 1? Well, I keep saying that, and I'm not seeing a lot of recognition on maybe I should write them out, is what I'm trying to say. Maybe, I forget. I teach all these classes. They're kind of the same. And I'm teaching Math 21 with finite math, which is business pre-calc, and I do logs there too. And maybe I haven't said this. Maybe I said it there, and I'm thinking I said it here. Let me just be really, really clear. So, 3 log rules. Let me just be super clear. Number 1, the log base b of x times y is log base b of x plus log base b of y. Have I not written that out? Maybe I haven't. I'm sorry. I apologize. I'm like, remember? No, you don't remember. All right. Yeah, so these are the 3 log rules. There's the first one. So multiplying for 1 log becomes adding for 2. So sorry, I feel bad. I went through all those problems assuming you knew one of the log rules. So these are the 3 log rules. There's the first one. The next one says log of dividing for 1 log becomes subtraction for 2. That's a big Y. Come on. It's a big Y over there. So those 2 rules making sense? And the third one is easier. It just says if you have like a power P, that power just comes down to the front. That's the one I was using in those other problems. There they are. Those are the 3 log rules that we're going to use a ton of in this section. Those are the 3 rules this whole section's about. Properties of logs. It means, just keep using those 3 rules over and over and over again. Good there? So we have those 3 log rules. Let me help you. You can write on my 3x5 card. You can get one of those cards every exam. But let me kind of summarize things for you in a way that would be helpful. Remember when you were a kid in math? What's the first math thing you learned when you were like kindergarten or first grade? You learn to add, right? And you start with adding, right? And then you got a little older next year, maybe later that year, subtraction came next. Adding, then you learned subtraction. Weren't those the good old days, right? Math wasn't too bad. It was just adding and then subtracting. Got a little older, you did multiply. And that was harder. I still remember being scared to go up in 4th grade. They do it earlier now, huh? I was in 4th grade. I had to go up to Mrs. Unmack's desk. So I remember my 4th grade teacher. I don't think she liked me. I was a hyper little kid. Anyway, they never liked the bad little boys. I don't blame them. But anyway, so I had to come up to Mrs. Unmack's desk and say my times tables. Everybody did in front of her. I was scared about those. Harder. And then dividing, right? So adding, subtracting first. Multiplying, dividing were harder when you're a kid, right? Let's use that. That works if you think about it that way for how these log relationships are working. Basically, what the rules are saying, first off, don't pay any attention to the base. We're not messing with the base at all, right? The base is just always there. The log base b, they're all log base b, aren't they? Those properties have nothing to do with the bases. It's just the x's and the y's and the power that we're moving. How do they work? Basically, the harder operation, like times, is for the 1 log. And the easy, right, it's times for 1 log, and it's just adding for 2. Easier. Adding's easier, right? You learned that when you're younger. That's like, a saying, it's like they say many hands make the job lighter. More people make it easier job. If you have a big job to do, you have more people, it's easier, right? That works for the logs. Let's just use that for our advantage, right? 1 log, harder job, times. 2 logs, easier job, adding. Same thing here. 1 log, harder operation, dividing. 2 logs is just subtraction. It's easier. Subtraction is easier than dividing, right? So see how those rules work? And you can, and then the power, that just comes down to the front. That's just 1 log. That's just move the power down. That's the simplest rule. And really the most important. We'll use that more than anything, actually. Anyway, is that making sense then? So 1 log added to 1 log multiplied, 2 logs added. Easier operation for 2 logs, harder for 1 times. Harder for 1 dividing, easier for 2 subtraction. And it makes sense that adding goes with multiplying, doesn't it? Because they both make things bigger. Adding and multiplying is repeated adding, isn't it? 3 times 7 is 7 added 3 times, so it makes sense. Multiplying is like adding. And dividing is like subtraction. They both make things smaller, don't they? So it makes sense they would go together. So there's the 3 log properties. There they are. So, yeah, I could say other ways, but good enough. So easier operation for 2 logs, adding, harder for 1 times. Easier for 2, subtraction, harder for 1, dividing. And the powers come to the front. Okay, so we have those, and let me just give all the log, maybe it's good just to have them all in one place. There's the golden, as I call it, log rule. I'm just going to give you all the log rules. When you lose or gain 1 log, it's in particular 1 log, we'll see later today, another about hour, why that matters, but just say it for now. When you lose or gain 1 log, base stays the base, other 2 switch. Right? You know that one? And finally, 1 log becomes 2. Remember how that works? If you have the log base A of B, you can make it B over A. High, right? It's the high goes high, the low goes low kind of thing. That's it. I just want to give you all the log rules in one place. That's all the log rules we're going to use in this section, the next section, probably, yeah, and this is the end of logs. This section in 5.6, which we won't finish today, but we'll finish on Thursday. And that's it. So if you just have those 5 rules for logs, you've got them all. So those first 3 properties, and then these 2, the golden log rule, you know, when you gain or lose 1 log. And then the special rule about 1 log can become 2 if you want. The high goes high and the low goes low. That's it. Those are the 5 rules, and there are no more, that we will use for logs. Questions on any of those rules? Those all good? So with that in mind, you want to go ahead and solve it. I'll leave this up so everybody can copy that. You want to solve that problem real quick now on your paper? The log base 16 of 8 plus the log base 16 of 2. So see how it's adding? It's adding for 2 logs. Easy job for 2 people. Easy job for 2. Just adding, right? Becomes harder. Becomes multiplying, for 1 log. And we're not messing with the base. Log base 16, log base 16, log base 16. That'll always be the log base 16. We're not talking about that. So everybody got that down okay? So it's going to be log base 16. And what do you do with the 8? 8 times 2. It becomes harder for 1 log. It's a harder job for just 1 person to do. It's times. So then that's log base 16 of 16. And what is that? Just 1, huh? Because we know the rule about the high goes high and the low goes low, and so that's just 1. Good. Is that okay? Questions on that? We all good? Shall we try another one? So those 5 log rules. So there we go. So log base 4 of 32 minus log base 4 of 8. Okay. So we're subtracting 2 logs. So go ahead and use those properties we learned. It's an easy operation for 2 people, for 2 logs, subtraction. It's going to become harder for 1 log. What's it going to become?
Log base 4.
Well, no, subtraction will become division. So we're not messing with the 4. We'll just leave that there for now anyway. It's going to become 32 over 8. Oh, I see. You're already going to the end there, David. Yeah, you're right. Yeah, no, you're right. You were a couple steps ahead. Yeah, it's just 32 divided by 8 instead of the 32 log minus the 8. Does that make sense? Minus, easy operation for 2 people, 2 logs becomes harder dividing for 1 log. Right? And then that's just log, like David was saying, that's just log base 4 of 4, huh? Which we know is just 1. Good on that? Questions? Now that I showed you the rules and everything, it's easier, huh? All right. So, it doesn't matter to me. I don't know if Mathxl's picky. I think Mathxl doesn't care. I'm pretty sure you can do it upper or lower. Yeah,
I just see you changing into big letters. I was just curious.
Yeah.
Like a thing.
No, it doesn't matter.
Okay.
Yeah. Okay, so log base 6 of 7 times log base 7 of 1296. You know what you can do with these? This is, I'm just going to, first off, notice, let me say a couple things it's not, rather than me just right away tell you what to do. You might think, well, is this one of those, Miss Harry, we should make it plus or something like that? No, because notice the bases are different, huh? This is not one of those first 3 properties. The adding becomes multiply, subtracting becomes divide. It's not those. How do I know? Because the bases are different. Those rules, right, if you look back here, let's look back. Those rules, one more. Those rules were all with the same bases, right? Same, B, 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 B. They're all base B, right? You can't be changing the base for these rules anyway, right? These 3 rules about the multiplying, adding, dividing, subtraction, and the power up front, the base doesn't change for those. You got to have same bases for those rules, right? But for these two rules, the golden log rule is about losing the base, and then the other one is about 1 log becoming 2. That's what we want to do. 1 log can become 2 with the higher part going high and the lower part going low, making it 2 logs, right? That's what we want to do on this one. Because, whoops, where am I at? There. Because looking here, you see, the bases are, one's a log base 6, the other's a log base 7. It has 2 different low down numbers, 2 different base numbers. So we can't like add them or anything like that. Instead, we just go, oh, the high goes high, the low goes low. Keep the times in the middle, not messing with that. The high goes high. Whoops, you got to write it right. It's 1296. The high goes high, the low goes low. Is that good so far? I just used that rule about turning 1 log, the first log into 2 logs, and the second log into 2 logs, and then see what we can do. That's just cross-canceling fractions. These are just big fancy fractions now, huh? Just cross-cancel those fractions, and then the rest just hit the buttons on your calculator. Just take log 1296 divided by log 6. I don't know what you say. Is it 6 or 5 or something? Somebody got a final answer for me? It's probably 4 or 5. I'm betting on 4 or 5. The 4? The answer's 4. So just on your calculator, just hit log 1296 divided by log 6 equals. See if you get a big 4. Everybody see what I did there? I just made the 1 log into 2, the 1 log into 2 with the high goes high, the low goes low. Cross-canceled fractions. Hit the buttons on the calculator. Good? Questions? All right, if you have any trouble with the calculator, grab me after class, just 10 seconds. I can. Okay. It's a weird one. Trying to think what would be the easy way to do that one. They're subtracting the powers. That's weird, huh? All that log stuff's up in the power zone. Isn't that a weird problem? What could we do?
Move that stuff to the front.
What's that?
Move everything in the front.
The front? We can move.
Because it's not a log, though.
Yeah, the base is not a log. Yeah, are you thinking of that one where powers come down to the front?
Third one.
Yeah, that's if this was a log 3,
Yeah.
I could totally move the powers to the front. But yeah, the base is not a log. Good observation. Not quite. So can't do that. Yeah, what? I mean, I know what to do now, but it'd be better if I gave you a second to. What do you think? I mean, what would you do?
So the upper part and then raise it to.
Okay. How do we do the upper part? Oh, you mean like turn them into 2 logs?
No, like just solve that part and then raise the answer to.
Gotcha. How do I solve that part? So what do I do to solve this part?
Divide.
Right. So you're saying just make it log 1 over log 3 like that, minus log 8 over log 3 like that. Yeah, high goes high, low. You could definitely do that. Notice it said exact value. Do not use a calculator. Now, I'm not going to, you're going to have a calculator on the test. Even the first part, you get the scientific, you can use calculators. But I wonder, though, you guys have a calculator? I wonder if it would come out, the answer is really 1/8. It's exactly 1/8, and I'll show you why in a second. I wonder if the calculator would be able to give you that exact answer, because this is going to be messy decimal. This part is going to be 0, but this is going to be messy decimal right here. And then I wonder if the calculator will be able to recover and turn it into an exact 1/8 or 0.125. Anybody got it on the calculator? Can I try it? Can I try it on somebody's calculator? What is the log of 8? Log of 8 divided by log 3. Not that. And then I can go, you got an answer pretty good, so. Nice, yeah, the calculator handled it. Turn it into 0.125. So yeah, if you can type all that in on your calculator, these calculators are impressive these days. You'll get a 0.125. I think they want to Yeah, they said fraction in the blue writing. Give me a fraction. So you could, that's 1/8. You can turn that into a fraction, that's 1/8. Now, that might not be the way you want to do that problem.
Can't you use that second rule like you said, because if it's the same base, the log 3 can be log 3 1/8 basically?
Oh yeah, I'm totally missing that. I was gonna tell you a fancier thing. That's a great way to do that problem. Yeah, I don't know why I didn't see it.
Missing something.
No, I was missing something. Yeah, that's nice. Yeah, I'm making this big deal. I'm just silly today. Yeah, totally. Right? Yeah. Right? Subtraction of 2 logs is dividing for 1 log. Huh? Yeah, that's a way better way. And then, remember how these cancel? How we learned when the base and the log match? Answer's 1/8. Yeah, that was easier. Good, thank you. Good.
I was missing something.
Carissa, right, Carissa?
Yeah.
Yes, thank you, Carissa.
I was
Good
like,
work.
look at the rule, like, I think that's
Does that make sense what happens? Everybody see why that happened? Because up here in the power zone, right, that's subtracting 2 logs, remember? Easier operation for 2 logs, subtraction becomes dividing 1 divided by 8 for 1 log. Harder for 1 log, dividing. Easier for 2, subtraction. Yeah, and then these guys cancel like we learned earlier when the base and the log base, when the base and the log base match, you just cancel them. It's 1/8. I was going to do something different. Good. Very good. So that's the easy way to go. Yeah. So whoops, kind of scribble that around there. Log base 3 of 9x. Okay, so see what they're saying is they want me to write that as 2 logs. So what is in the middle between the 9 and the x? It's times. That means 9 times x. So 1 log multiplied, harder job for 1 log. I'm going to turn it into 2 log base 3s. What's it going to be with the 9 and the x? What's going to be in the middle?
Plus.
Plus, right? Harder job for 1 log, multiplying becomes easier adding for 2. And the base doesn't change, right? All those first 3 rules, the base doesn't change. Good? That's all they want from you on that one. All right. Reminder rule. Okay, yeah. So log base 7 of z to the 9th. They basically want me to take that 9 and bring it down. That's all there is to do on this problem. 9, whoops, it's a scribbly 9. 9 log base 7 of z, done. Is that good? That's just that third property that powers come down to the front. That's an amazing property, and it'll help us do a lot of things we'll see even today. It's a kind of an amazing, but that powers, things in the power zone can come down to the base zone. That's really a surprising thing, and will be you'll see it's going to be very useful to us, especially, and then on Thursday we'll solve some financial problems. We'll have like letters up there in the power zone, and we'll need to use the logs to bring them down, and we'll see how it's very useful to solving a lot of financial problems. Anyway, there's the answer. They said express powers as factors. Do you understand their lingo? Powers, that was a power. Now it's multiplied, meaning it's a factor. A factor is a thing multiplied. So we did what they wanted. Take the powers and make them multiplied. All right. Anyway, the thing now we're about to go into on the next problem, so let me just go to a fresh screen and show you. Do you guys remember fractional powers? Like, what is x to the 2/3? Anybody remember that? Actually, wait, before I go there, let me just do a little reminder of powers. What is x to the negative? That's supposed to be a 2. Looks like a z. What is x to the negative 2 power? What does that mean when you have negative powers? You remember that first off? Yeah. It means like that, huh? The whole thing goes to the bottom, right? Negative powers jump to the other side. They flip it to the other side, don't they? And then the power becomes positive, regular 2, after the jump. You remember that from your algebra days? So, this course, pre-calculus, you know what they could also call it? Advanced algebra. That's what it basically is, right? You did these rules before in basic algebra maybe, intermediate algebra for sure, and now we're doing them again. Really, they could call this advanced algebra. We do all the same rules, but they're just going to push them harder and make them uglier and make us use them all back and forth, getting you ready for calculus. This is like advanced algebra. All right, so then do you remember, what do fractional powers do? Anybody remember that one? It's a little weirder. Remember, the denominator swings into the hook, and it becomes a root. you remember that fractional powers are roots? In fact, you could write the rule like this. X to the a over b, the b swings around. It's the bth root. Sounds kind of weird. The bth root. The bth root of x to the a. That's the rule for fractional powers. So we have two rules that are important to know. Negative powers flip things, and fractional powers root things. And you want to be clear, they're going to push you on those two rules. They're going to push pretty hard, and calculus will also. And people coming out of Algebra 1 or Algebra 2, they know it a little bit, they've seen it, but they don't really know it the way they need to know it to survive in calculus. So that's the kind of thing I want to make sure I help you with. This is what makes people live or die in calculus. It's all these little rules. So we good on that? Do you remember that? So fractional powers, notice the top, like the 2 here, that just stays. That didn't go anywhere, huh? The numerator of the fractional power just stays. X to the 2, x to the 2. That hasn't changed. But the 3, that's the part that swings around and ends up in the hook. So third root of x squared. So that's, and sometimes we prefer this format. Sometimes we prefer that format. Just depends on what you're doing. Sometimes they'll say, hey, make it fractional power. Okay, now make it look like a root. Okay, now go back. The different such things you're going to do at different times. One form is more useful than the other. They're equal to each other. You can put it either way. It's true. Both are right. Really, in calculus, this one's a lot more useful because you'll do derivatives and you'll do stuff with powers. It's way easier. I'm always telling my calculus students, when they give root problems, I say, just change that to a fractional power right away. Problem be a lot easier for you. So it's a lot easier to just change everything to these fractional powers when they give you roots. Don't stay with roots. All right. Anyway, with all that said, with that said, tell me, what is x to the half power? Can you do that one real quick? Do the same rule we just did and simplify it as much as possible. What's x to the half? So fractional powers, the 2, where's the 2 go? Oops, things going crazy on me here. It swings around into the hook, and the x to the 1 just stays x to the 1. That doesn't go anywhere, right? The top numerator power just stays put. The bottom swings around into the hook. Okay, great. So what? So it's 2 root of x to the 1. Can we write that more simply?
Square root x.
It's just root x, huh? The 2 is understood, and the 1 is understood. So what's my point in all that? In the problems we're about to encounter, they're going to give you the square root of blah, 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 some big fancy thing, And you want to realize right away that that's the blah, blah, blah to the half power. A root is a half power. That's the part that needs to be crystal clear in your mind. Does that make sense? Right, we just proved it up there. Anything to the half power, the 2 swings around, it's the square root. And if you write nothing in the hook, it means 2. And if you write no power, it means 1. The 2 and the 1 are understood, assumed, aren't they? So if they give you root of whatever, blah, 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 you can just get rid of the root and turn that into a half power. It's the same thing, and it's easier to use half power. Same thing in calculus. Go into Math 5a, calculus. If they give you roots, just change those to half powers. Way easier to work with that way. I'm always telling my daughter that as I'm doing calc with her. Just change it. Change it to a fraction power. All right, so let's go now. All right, so you got ln of x to the 4th, root 4 minus x. All right. First thing to do, what do they want me to do? Make it a sum or difference, meaning make it an adding or subtracting, right? Sum means add, difference means subtract. They're saying, hey, make this into adding and subtracting logs, plural. Make it more than 1 log. Right now it's just 1 log. Make it more than 1 log, added and subtracted. How am I going to do that? Well, what's right in the middle here? Times. Isn't that x to the 4th times the root? Right? So then just make that, so multiplying for 1 log, and natural log is the same as any other log. Doesn't matter. Natural log, regular log, whatever. Same rules. Multiplying, a harder job for 1 log, becomes easier, what? Adding. For 2 logs. Good so far? We have one more step. But is that good so far? Multiplying for 1 log, harder operation for 1, becomes easier just adding for 2 logs. Good so far? And now I can do the powers to the front thing, right? So that 4 is going to go down here to the front. And what about this root? Yeah, here's where the half thing I was telling you about. Just make that a half power. Get rid of the root and instead make it a half power, which is the same thing as the root. And then that comes to the front. So we get 4 ln of x plus a half ln of 4 minus x, and we're done. That's what they wanted. So we just use the rules, those properties. Questions on that one? Making good sense? By the way, it is important. If I leave these parentheses off, Mathxl is gonna mark it wrong because it doesn't. You have to put parentheses because you're showing the whole 4 minus x is plugged into the log. So make sure you keep parentheses to be clear on that. Okay. So. All right, let me let you try that one. So, same kind of thing. They want you to break it into more than one log, right? Sum or difference, adding, subtracting, more than one log. So go ahead and do that. Don't worry about that x greater than 2. I'll explain that later. You don't have to do anything with that. Ignore that. You know, this thing, just ignore it. So it's dividing for one log, isn't it? Right, a fraction means dividing. It's x to the 9th over x minus 2. It's dividing for one log. So that'll become what for 2 logs? Become easier, right? Easier job for 2 people. Easier job for 2 logs. And the base is not going to change. Whatever it is, it's log 5. Base 5. So x to the 9th, what? Minus x minus 2. But you have to put that x minus 2 in parentheses. Good so far? And then one other step. What is it? The 9 drops down. And we're done. Oops, it's supposed to be 2. No, it's broken. I don't know why it's not working. Anyway, there we go. So I'm finger painting on the screen today. And I probably will be for 2 weeks as I send it back to the factory. I don't know if they'll take it back. Good? That making sense on that? Again, I want to make clear, well, first off, the basic rule, right? A fraction is a dividing, right? And dividing for one log, harder operation for one log, is easier for 2. It's just subtraction. If you don't put these parentheses, I know I've already said it, but I want to make it make sense for you why they're picky about that, because that way I think you'll remember it better. If you don't put those parentheses on there, what you're really saying, Mathxl is not just being picky, they're right. You're really meaning this. You're meaning, if I wrote this without parentheses, the reason that's so wrong is because you're really saying this. You're really saying, hey, x is plugged into the log function, the toaster, so to speak, and then 2 is subtracted afterwards, outside of the log deal. That's what it means if you don't put parentheses. It means only the thing right after the base is the plug-in. If there's no parentheses, the official notation means that only the thing right after the base is the plug-in. Now, if you mean for the whole thing to be the plug-in, you got to put parentheses. So that's the difference. It's a difference in meaning, really. So make sure you do that. Questions on that one? We good? Why did they say x greater than 2? Why is x? We don't have to do anything with it. But why did they even say it? I mean, why are they even saying x greater than 2? What if x is not bigger than 2? Why are they saying that? What's that? What'd be negative? There'd be a domain problem right there. Yeah, you can't put in things less than 2, or even 2 itself. Right? Because remember, the inside of the log can never be 0 or negative. Remember that? We're going to use that even today. So let me just remind you that. Remember, the inside, you can't take log of 0 or log of negative 3 or whatever. Error. So you cannot put inside of any log, natural log or any log, 0 or negative. It's not allowed. Right? That's where the vertical asymptote line always is. On a log graph is where the inside of the log becomes 0. Huh? So that's why they're saying, they're just reminding us that x has to be greater than 2 or this thing won't even work. We don't have to do anything with that. Nothing's required by us. They're just reminding us of that. Now, Mr. Karen Bacchus did all these with you? But you guys didn't seem to know the log properties when I talked about the log properties. All right, I know different styles, and we're all different, and it's been a weekend. All right, so first thing is to grab that half and pull that half to the front. So pull that half down to the front. Good there so far? Right, just powers come to the front, right? That half power just goes right there to the front. Oops, I missed. So the half power comes to the front. And then, you know what I would do with that top? Yeah, that top's factorable. Can you factor that top? Like the FOIL, like the two parentheses, you know? X is in the front. Remember, it's what multiplies to be the number at the back. I can't write multiply with my finger. And what adds to be the number in the middle. What number's in the middle? -1. So what times what is 20? Yeah, 4 and 5. And, right, because that'll make 20. That'll multiply to be 20 at the back. And how do I get the middle to be -1? That's what's really in the middle. Yeah, good. The sign in the middle always is taken by the bigger of the two, right? So we have negative in the middle, -1 in the middle, so that means the 5 gets the negative. Yeah, again, the sign in the middle is taken by the bigger, plus on the 4. Because -5 plus 4 would be -1 in the middle, huh? And they would multiply to be negative. Positive times negative would be -20. So that's the top. Yeah, so we have a half natural log of, well, here, I don't need to rewrite it all. Next step. So now we have the top factored in the bottom. So now what are we going to do? Now they want me to break it into several logs. The top, those are times, aren't they? Right? Aren't these multiplied? So they're going to become added. The half that's in the front right now, when I break this one log into like 3 logs, that's what I'm going to do. Because there's, why? Because there's 2 things on the top. There's an x plus 4 times an x minus 5 on the top, divided by, so subtraction, the x plus 3 to the 5th power on the bottom, right? So it's going to break into 3 logs. The 2 things added on the top, the 2 things multiplied on the top will become added logs. The thing divided on the bottom will become a subtracted log, right? Because dividing becomes subtraction. Multiplying becomes added. And the 1/2 that's in the front, when I break that 1 natural log into 3 natural logs, that half will have to go to everybody. Because he was in front of the source that led to all 3. So he'll have to go to everybody. So it'll be half natural log of x plus 4 plus a half natural log of x minus 5 minus a half natural log x plus 3 to the 5th out on the screen, yeah. And we have one more step, small little step. Got to move that 5 down, but otherwise we've got it. Everybody see what happened there? See how the 1 log multiplied and divided becomes 3 logs added and subtracted. And last step, that 5 will come right there. So we get a half natural log x plus 4 plus a half, whoops, natural log x minus 5. Minus, no, when that 5 hits the half, it'll go to the top because it's 5 over 1, huh? Become 5 halves. And there we go.
No, they're not like a base, it's just, those equations are just next to the element, right? It's not a base or anything.
No, it's not. Yeah, nothing's lowered down. The base is E, but they're not showing it. Yeah, yeah. These are just right next to it. Technically plugged in. It means f of natural log of. It's like plugged in. But yeah, just sitting. It's not lowered down or anything. You're right. Is that good? That okay? Questions I can answer on that one? Getting the hang of these properties? Get All right, so same kind of thing. Can you break that one log into several logs? See how you have 6x multiplied by the root on the top, divided by the x minus 3 to the 12th. So that becomes subtraction. The root, you remember that's a half power. So that'll put the half in the front and all that kind of stuff. Don't worry about the x greater than 3. We don't have to do anything with that. We good to there so far? There's more to do. So how I just broke it up because it was 6x times the root on the top, so we can plus. So for several logs, it's easier operations, adding and subtracting. For one log, it was multiplying, dividing, harder. Okay, now if you wanted, you could break up the 6 and the x. I don't think Mathxl will require that. I think you can just, you know what I mean? You can make it natural log 6 plus natural log x. That's on the test, I don't care, either way, right? I mean, normally we would just keep it 6x because that's pretty simple, right? But it technically, it is times, and you could make it 2 logs added if you wanted to. Doesn't matter. But let me say what does matter. If I just leave it like it is right here, you could do this, or you could do natural log 6 plus natural log x. You see what I'm saying? Either way is right. But technically, you have to have parentheses if you're going to keep the 6x together, or that will be marked wrong by Mathxl. Does that make sense? You see why that is? Because you got to let it know the 6 and the x are both part of the plug-in, not just the 6. So all right. So now, what do you do with the what do you do with this root? What does this root mean? Yeah, it's a half power, huh? This is half power, and half power come to the front. Half power in the front like that. Bless you. Like that. And then this 12 will come to the front. And we're done. These all making sense? No questions? Got it down?
The teacher.
What's that?
He didn't like that we didn't ask a lot of questions.
Yeah, you guys are a very, very quiet group. I know. I feel like I'm begging for questions too. But you did very well in the first exam, so.
Definitely went through this whole section. This is much different than the way he was teaching it.
Different, huh?
Much different, yeah.
All right, so this one, we're gonna play the game the other way. They want us to take the 2 logs and crunch them together. See how they say make it a single log? Make it into 1 log. So they want us to basically run the problems we've been using backwards. So now put the 2 and crunch it into 1 big log. All the same rules, just running them the other way. Single log. See how the bases are the same? They're both log base 2. So, we don't mess with that. That just stays log base 2. So what does that 4 do that's in the front? Where's it going to go? To the power, and that 3 to the power. So it's going to be u to the 4th times v to the 3rd. And you technically do need parentheses, so you know it's all part of the plug-in. And that's it. Is that good? See what happened there? Right? So those numbers in the front go back to the power. So I'm just running the rules backwards now, huh? To make it into 1 log. It's times a harder operation for 1 log. It was easier, it was just adding for 2 logs. Right? So it's the easier for the many people, harder for the 1. Times for 1 log, adding for 2 logs. All right. All right, try that one. Let me give you a second. That one's got some tricks to it. Got to make them into one log. Same kind of thing. They want you to take those two logs and put them together into one log. Is that good so far? I would not make that. Well, I'm going to make the root into a half power, but now, not earlier. So I don't want to put it to the front. Probably not making much sense out of that. So you're good so far, right? And then that's log base 5. I'll show you what I mean. X to the half over x to the 7. Good so far. Remember, root on anything's a half power. We have to combine those two x's into one. We good so far? How do we do it? How do we do this piece of the puzzle? How do you just forget about the log for a minute? What do you do with x to the half over x to the 7? What is that?
Can you move it up to the, and say x to -7?
Yeah, you totally could. That's what it is. How about what you're saying is true? How about I say it this way? I think you'll remember it the easiest way possible. What if you had like x squared over x to the 5th? Remember what that is from your algebra days? So here again, we're hitting on those algebras. We're just pushing them harder. So same rules, but just pushed harder. Remember the rules? When you have like a couple x's, different powers, what do? Subtract. And the bigger one's on the bottom, so it'll be x to the 3rd on the bottom, right? Wherever the bigger one is, that's where the answer ends up, right? So that's what we have to do here with a half. So in other words, what I'm saying is this is going to become log base 5. Oops, kind of getting scribbly there. Log base 5. And the half, x to the half minus 7. Right? Well, that's not very well. Yeah, okay, we can do that. You can just take the top minus the bottom. How about we just do it that way? I just took the top power minus the bottom. A half minus 7. What is a half take away 7? Isn't it negative 6.5? Right? A half, take away 7. If the football team gains a half a yard and then loses 7, they're back 6.5. You gain a half a dollar, you lose 7, you've lost $6.50. Now, we can't leave it as a mixed number, so we have to convert this. Remember how to convert mixed numbers to improper fractions? You multiply the bottom and add the top. 6 times 2 is 12, add 1 is 13. Kind of running out of room here. So it's log base 5 of x to the minus 13 halves. 6 times 2 is 12, add 1, 13. Good there? See what we've done? So when you have x's in a fraction, top and bottom, you take the top power minus the bottom power. Remember those rules from algebra? And then that's minus 13 halves. Now, I think they don't want a negative or something. Don't they say something like that? Type an exact answer. Use integers or fractions for any numbers in the expression. I think they... Oh, yeah. They want us to bring that negative 13 halves to the front now. That's all. Bring that to the front. So the final answer is negative 13 halves log base 5 of x. And there we go. Is that good? Getting the hang of all these rules? Questions I can answer? Half an hour left, so I want to... Okay. All right, let's try that one. Log base 4. X squared minus 49 minus 5. Log base 4 of x plus 7. Okay. So combine those. Again, we're crunching 2 logs into 1 log, right? Put them together into 1 log. What are you going to do with that 5 that's in the front of the second log?
Exponent.
Yeah, power. It's going to shoot up to the power zone, right? And then subtraction, right here in the middle of two logs, easy operation for two logs, so just subtraction. It's going to become what? Dividing for one log. Harder operation for one log. So log base 4 of x squared minus 49 over x plus 7 to the 5th. That 5 goes up here, huh? Good so far? Good to there? And then one more thing. We can factor that, huh? That x squared minus 49, right? X plus 7, x minus 7. It's going to cancel one of the x plus 7s down below. Exactly. You guys are tracking with all this. You don't have questions because you understand everything perfectly. Is that what you told Mr. Karambakis? Log base 4. This will cancel, leaving 4th power down below. It's my 7 over x plus 7 to the 4th. And there we are, we're done. We made it one log, like they wanted us to. Questions on that one? All right, we've been through a mess of these things, and we're out of the woods. Did y'all get that last one? Did I go too fast? Anybody else need to see that? You guys got that right there? Good, that last one? All is well. Okay, so let's try this one. Ooh, ugly. All right, same thing. They want us to make it a what? A single log. Let's put them all together, crunch them into one log. You know the rules. Adding becomes multiplied. Subtraction becomes divide, right? So here we go. So it's going to become, and I'm just going to make it one ln. You can capitalize it or not, doesn't matter. X over x minus 1. And then I'm just going to make it one big old fraction. The other x plus 1 goes on the top. The other plain x goes on the bottom. And the x squared minus 1 goes on the bottom also. I have one more step. Well, one or two. But is that okay so far? Why does this one go to the bottom? Because it's subtracted. Exactly. Right? Subtracted means divided, or another word to put that, denominator. Right? Anything in the denom is divided. That's what it means to be in the bottom of a fraction. You're divided. Right? Does everybody see that? See how the first two logs are added, so that's just like straight multiplying. Top with top, x with x plus 1, bottom with bottom, x minus 1 with x. I just went straight. So for the first two logs, I just went straight, straight. Top to top, bottom to bottom, right here. Straight, straight. Right? Because they're just multiplied. But the third log is subtracted, so his x squared minus 1 went down here to the denominator, right? We all making sense out of all that? So now what?
Factor.
Yeah, factor and cancel stuff out, huh? So it's going to be ln of x times x plus 1 over x minus 1 x. And then this part right here will become x plus 1, x minus 1, huh? This guy. Right, I factored the x squared minus 1. What if that had been an x squared plus 1? What's the story with x squared plus 1? Is that factorable? No, remember? That's I'm always beating that drum, huh? I'm hoping none of you make that mistake in calculus. It's very, very common and cause a lot of trouble. It's not x plus 1, is it? It's not true. Only the minus can be factored. If you're not convinced of that, try it on your own. If you think it's x plus 1, write that, FOIL that out. You'll see that's not x squared plus 1. It becomes 2x in the middle. It's not the same. All right, anyway, so x cancels x plus 1 cancels, not that one. Whoops. Here, I'll fix it. I'll make that the plus. There we go. So the plus cancel. What are we left with? X minus 1 squared in the bottom. So it's ln of 1 over x minus 1 squared. Right? That's all I'm seeing. Yeah, there's just two x minus 1s in the bottom, huh? Good? Here's our answer. We made it, what'd we do? We made it one log. They said make it a single log. We did. It's one log. Questions? We good? Getting all these rules down? It's about the worst stuff in the homework is right here. All right. Yeah. All right. We'll do one more. Hey, you see what's going to happen with that 2 power? Let me help you. Let me speech it to you. That 2 power is going to come up here, hit on the root, take the root out. Right? It's going to 2 power that root, right? That 2 in the front of the first log is going to zip up to the power, and there's going to be a 2 power on the root. What happens when a 2 power hits a root? Cancels it out, huh? So root's just going to vanish. Do you see that? So it'll just be log base 3 of 9x minus 5. The root, the 2 power, they cancel each other out. And it just becomes log base 3 of 9x minus 5. No more root, no more 2 power. Everybody see what happened there? So the 2 in the front went up here. Right? Numbers in the front go to the power, and then it hit the root, canceled out the root. And so that's that one. That's the tricky part there. Okay, now, what do we do with the other part? Well. It's going to become log base 3, 9x minus 5. Now, the log in the middle, this one, is subtracted. Subtracted. What does that mean? It's going to flip it. Do you realize that? It's going to be, yeah, I don't know how to say it clearly. It's going to end up, instead of being times 4 over x, it's not times 4 over x, is it? If that was added log, it would be, right? If the log in the middle was added, adding becomes multiplying, right? Then it would just be straight times 4 over x. But instead, it's really minus. It's really minus in the middle, so that means it's divide by 4 over x. And what does divide by 4 over x do? What do you do when you have a fraction and you divide it? What do you do with the fraction on the right always? Flip it, reciprocate it, right? So really it means flip that 4 over x to be what? X on the top, 4 in the bottom. See what happened there? Getting the hang of all these little rules. This is what makes a calculus student successful. Really, it's true. Calculus itself is not that bad. It's all the mess of algebra behind it. So if you get all these down, calculus will not be that terrible of an experience. Making sense? Good with all those rules, right? So subtraction means divide. When you divide by a fraction, you flip it. X over 4, right? And then the last one is added. So his 4 will go on the top, because adding means multiply, which means top, not bottom. Good? And then can we cancel anything? Yeah, the 4s, huh? We can cancel these 4s. Boom, boom. And there's our answer. The answer is log base 3 of 9x minus 5 with an x. There it is.
Do you have to distribute that x?
No, you just leave it. Or distribute. It's good either way. Is that okay? Questions on that? So subtraction means to flip a fraction, doesn't it? Because it means divide. Dividing a fraction is flipping it. And adding means times. Just keep it straight. Question?
Does it matter if we distribute it?
Yeah, it doesn't matter. If you want to distribute it, feel free. If you want to leave it, feel free. I believe Mathxl will take it either way. I will certainly take it either way on a test. Oh, we followed their instruction. What was their instruction? Make it a single log. It's now a single log. Distributed or not. Out of the woods. All right. Let's try that one. I guess we'll do one more. 2 log base a of 7x to the 7 minus 1/3 log base a 8x plus 7. So the 2 goes up there. The 1/3 goes up there. So it's log base a of 7x to the 7 squared minus 1/3. Oop, supposed to put that 1/3 up, huh? X plus 7 to the 1/3. Now, what does that 2 power do on the 7x to the 7th? What's that 2 power do? Remember, here again, I'm pushing an algebra rule. You've seen it, but how well do you really know it? And that's what calculus is all about. They just push these rules every which way. So what does that power do? So 7x to the 14th? Oh, added? Should be 9, you mean?
No,
Multiply? Am I good?
It's inside the parentheses,
So log base A, 7x to the 14th?
No, because that leaves out the 7 and the x.
Yeah, what do we do with the 7?
Or yeah, it's the, yeah.
So the rule is, it's funny, it's like we know these rules, but we don't know them well enough, huh? That's what calculus, that's what we're doing here, and that's what calculus is all about. You have to know these rules really well. So powers outside parentheses multiply other powers, not bases, powers. What other powers? 7 has a 1 power. Boom, boom. 7 squared, x 14th. And that 7 squared is going to become 49. Let's just make it 49. So you square the 7, multiply the 7 power. 49x to the 14th. That's the right answer. Remember all those? All that little stuff.
basically distributing.
Yeah, it distributes to other powers. Yeah. And then divided by, because of this subtraction here, 8x plus 7 to the 1/3. We're done. Good. The subtraction becomes a big divide for 1 log. Harder for 1 log. Good on all that? This was a 7. I don't know if it, there you go. It looks a little better now. All right. That's long section. All right, one more. 4 power, just going to yank it up there. I'm going to whip this one out. Log base 5, it's going to be x plus 6. I'm going to do it in one step. The 4 power goes up there. The other 2 go to the bottom, and we're done. It's almost easier to do in one step instead of fiddling around. Does that make sense? They're all the same log base 5, right? So the 4 power goes up to the x plus 6, and then the 2 logs that are subtracted become denominator, divided. We good? There, does that make sense? Good question I often get about this is people say, wait a minute, Sarah, now subtraction should be divided. Shouldn't it be like double divide or something like that? Don't worry about all that stuff. Anything in the denominator is really divided. Let me ask you this. What if this last log, the third one, was plus log base, that's a scribble there, was plus log base 5 of x minus? What if it was plus instead of minus? Well, then that x minus 5 would end up here, wouldn't it? So it doesn't matter what the order is. That's the thing I think that confuses people on these. Sometimes they go, what if it's at the end or the middle? Doesn't matter where it is. If there's a plus sign in front of any log, it's going to the top. If there's a minus sign in front of any log, it's going to the bottom. Doesn't matter what the order is. It matters what the sign in the front is. Plus in the front, multiply, top. Minus in the front, divide, denominator. Hey, let me prove that to you. I'm not going to do formal proof, but let me show that to you by another rule that you already know. Sometimes it's helpful to see a rule demonstrated, a truth demonstrated through 2 different rules that you know both already. It solidifies them. Think this way. When you have a minus in front of that log base 5, x minus 5 thing, another way you could see the truth of that, about why it goes to the denominator. I mean, you already know the rule. Subtraction means divide, right? But here it is said another way. A minus in front of a log is really a minus 1, right? And what could you do with numbers in front of logs? Power. So what does a minus 1 power do on that thing? Denominator. Same truth by another rule. That's kind of what happens as you get better and better at the algebra rules. They start to confirm each other. And you can see the same truth from several perspectives. That's what's supposed to solidify as your algebra strength grows. You start seeing, oh yeah, these rules are all saying the same story. Negative powers, denominator. front of a log, negative power, denominator. Or subtraction, divide, denominator. Same truth, said two different ways. All right. Made it through the terrible stuff. That is messy, difficult stuff. All right. So remember how to do this? What do you do with when you got a weird old log? You got one weird log base. It's a weird base. Base 3. They want you to use calculator. What are you supposed to do? You don't have a log base 3 button. Now some of you do with the fancy, some of the calculators do, but most of them still don't. So weird old base 3. You don't have a weird old base 3, most of you. You just have a base 10 and a base E for natural log. So how you can do log base 3 on your calculator? What are you going to do? Remember the rule, the 5 rules I gave you, the 5th one, the last one said how to turn one log into 2. The high goes high, the low goes low. Just make it log 21 over log 3, then hit the buttons on your calculator. It's going to be 2 point something, I think. 2.7, blah, 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 blah. Is that good? So remember that rule? You got one log, you can make it into 2 with the high goes high and the low goes low.
So it's log,
Those are base 10 logs.
log base 10 of 7. Is that what it's saying? Because it's 21 over 3?
No, it's log base 3.
Okay.
The 3 is the base, the 3 is lowered down, of 21. I'm saying is the same as log base 10 of 21 over log base 10 of 3. That's what it's technically called the change of, yeah, they say it here, change of base formula. Because really I changed from log base 3, because I don't have a log base 3 button, most calculators, to 2 log base 10s, because I do have a log base 10 button. That's technically what we did. You don't have to write those 10s. You don't have to mess with any of that. Just let the high go high, the low go low. But that is technically what we're doing, is changing the base. That's why they call it that. Changing it to a base we have a button for, right? All right. Okay, so now they want you to type it in your graphing calculator. There's a graphing calculator one. And they even give you the window size right there, you know, the X and the Y. I'm not going to take a lot of time because it'll be real easy for you. So graphing calculator. I just want to show you what you'd put into Y1. What are you going to put into Y1? Well, you're going to put the function in. I mean, it's log base 12 of X. Well, the problem with that is you don't have a log base 12. You don't have a way of entering log base 12, probably. There might be some special log thing I'm not aware of on the graphing calculators. But anyway, I know how to put it in without that. What do I do when I got a weird old base?
Log of X over log of 12.
Yeah, the high goes high, the low goes low. Like that. Hit the graph button, make your window right, hit the graph button on your calculator, and you will get the picture.
Which is not log base 10 of X over 12. That's not the same thing, right?
You're saying it's not log base 10 of X over 12 like that, right?
Right.
Right, that's not the
Not
same.
that, okay,
Yeah,
right.
it's log base 10 of X over log base 10 of 12. They two separate logs. Yeah, the rule is one log becomes 2 logs. This is not right because it's only 1 log still.
Right.
Right. Good, yeah, so just do that. You know, same thing, high goes high, low goes low, hit the buttons. Let's show. All right, little trickery here. So these are not super important. I mean, we're not going to do them later in the course, so I'm just going to do them quick. They are a little tricky. Basically, I got log of 13x plus ln of c over there. I'm going to use the rules of logs. Over here, 2 logs added. 2 logs added becomes 1 log multiplied. You don't have to put the dot. I'm just emphasizing. You can just write 13xc. It means multiplied. Good so far? Adding for 2 logs. Easier operation for 2 people. Becomes a harder job for 1 log times. Okay, now what? So what? What do they want me to do on this? Well, solve for y. They want y alone. They want y alone. Well, I've got a log on the y. How do I get rid of that log? I can divide off the log on both sides. No! No, please never do that. That's a serious misunderstanding. Now, the answer is going to look like we did that. Here's what's weird. I just said no, in harsh tones, no. But the truth of the matter is, the answer is y equals 13xc. You think, yeah, well, what's your problem, Mr. Aaron? We just divided off logs. No, we did not divide off the natural logs. That's not why that means that. And you might think, well, whatever. It's the same answer. No, whatever will matter. In another problem, it'll come out different if you're thinking that, and you'll do the wrong thing. This one, you would have got away with it, but you won't always. So it's important that you know that difference. We're not dividing. Why am I not dividing? First off, let's just say that. Why is it not dividing? Because it's not times. That does not mean ln times y. That means ln of y. I know I'm always beating that drum. You can get that down. It'll help you so much in calculus. Because it's not just ln. It's sine, cosine, tangent, e to the x, regular log. They're all functions. They're functions. That's why I'm always doing the toaster thing. Because I'm helping you think that y is plugged into the function. That 13xc is plugged in. In other words, what I'm saying, it's like f of y and f of 13xc, right? That doesn't mean f times, you know quite well. You can't divide off that f. That f is, that argument, that's plugged into the function. Well, that's what natural logs are. That's what sine is, cosine is, tangent is. Those are all functions. These are things plugged in. Just because we write them next to the sine or cosine or tangent or ln or regular log with parentheses doesn't mean it means times. Don't make that mistake. It doesn't mean times. It means plugged into the toaster. So, okay, so what? So it's not times, so we can't divide then. So we can't divide by sine or cosine or tangent or ln or regular log. It's not dividing. These are plugged in. Okay, so what then? What do we do? By logic, we remove them. Now you think, oh, you're just using fancy words, Mr. Heron. It's the same thing. No, on the next problem, that'll make a difference. It's by logic. It's not by dividing. It's just, hey, if the ln of one thing is equaling the ln of the other, those plug-ins must be equal, or ln of one of them wouldn't equal ln of the other. By logic, I know those plug-ins have to be equal, not by dividing. And again, you'll see why that matters on the next problem. So there is the answer, looking as if we divided, but we didn't. All right, so then on the next problem. Okay, so ln y is 7x plus ln c. Now, the person that thinks dividing would just go, oh, just divide, it's just y equals 7x plus c. These are easy. That's wrong. That's not true. That's the wrong answer. So, let's don't do that. I'll erase that and I'll back up. But I want to make sure we're clear on what's, because that's what I see a lot on tests and things like that, is people kind of just monkey see, monkey do, sort of imitate, and they're not really getting the rules. That's not true. Here, it will be exposed. Why is this one so different than the last one? I mean, it seemed like it worked on the last one. Why is this one so different? Can you tell? What's different about this one? Right. This one, all the pieces have logs. Log, log, log. There's nobody outside of a log. They all have logs. But the new one, he's got a log and he's got a log, but he's like, I'm a no-logger. He's not a log. So you got to really know what you're doing here. They're not all the same thing. Okay, so what do we do then? Well, there's a couple ways to do this. And you won't see it now, no. Let's subtract ln c from both sides, and we get ln y minus ln c is 7x. Get the two logs together. This is just one of many ways to do this problem. Get the logs on the same side. Now, what is 2 logs subtracted? What have we learned about that? It's 1 log divided. Like that. We good? Everybody happy with that? Right? 2 logs, easy operation, subtraction, is a harder job for 1 log. It's dividing, right? Okay, now we're down to this point. What are we trying to do? We're trying to solve for y. We want to get y alone. It's plugged into a log. It's got a c under it. How am I going to get that y alone? I'd like to get rid of this log, wouldn't I? That'd be nice. So how do we do that? Can I just drop it off there? Just y over c is 7x? Multiply by the c? No. Can't do that. What do we do when we want to get rid of a log?
You add to make it a one.
The base stays.
It's the golden rule of logs, right? Remember when you cross off the log, what happens?
Base stays the same, the other two switch.
Yeah, it's the gold. Make sure you know that rule well. It's the gold, it's the fun. Remember, I give you the 5 rules, right? The 3 properties, and then the high goes high, low goes low, and then the golden log rule. I wrote back at the beginning of our time together, right? When you cross off one, this is why I emphasize. This is why I made a big deal. If you look back to the beginning, when I wrote the golden log rule, the very first rule we learned when we first started logs 2 weeks ago or whatever, was when you remove one log. See, I wanted to make that clear. See, I'm not crossing off 2 logs here. That's where I'm distinguishing. See, the last problem on this last line, I got rid of 2 logs by logic. That's not the golden log rule. I didn't do any base, nothing to that. It's just by logic, if ln of one thing is ln of another, those things must be equal. I got rid of 2 logs by logic. But on this one, I'm getting rid of 1 log. That's different than 2 logs. It's not by logic. It's by the golden log rule, which says when you lose 1 log, or gain 1 log, the base, who's the base? E. The base stays the base. The other 2 switch. Never forget that. It's the golden rule for a reason. It's really important. So they switch. Instead of e to the y over c, it's e to the 7x, and the y over c goes over there. Right? That's the rule we know. That's the golden log rule. Be really clear on that one. See what's hard about these rules is they're similar with slight differences, aren't they? That takes practice. That just took me time. Took me hours. I gave my life to these kind of math classes. Just doing my homework forever. And going, why is that doing? What's that? And I go find my teacher in the halls. Why does this one? And he goes, see? I go, oh, yeah. You know, it takes lots of practice. So you see the difference there? It's when you lose 1 log that the base stays the base, the other 2 switch. Last step, now you just multiply by the c, huh? So c e to the 7x, y is alone. There it is. Good on that? See that? Oh, look